Hello everybody, welcome to today's lesson on using the volume of curved figures to find other dimensions of those figures. For today's lesson, you're going to need a calculator, your math notebook, or some other paper to take some notes and do some examples with me, and of course a pen or a pencil. If you need to pause the video at this time to go gather up your materials, please do so, and you can resume as soon as you're ready. All right, we are going to start with the sphere. What I would strongly encourage that students do right now is pause the video, draw a sketch of the sphere with the given information. The volume given is 57 cubic inches. And then near your problem or your sketch, I would jot down these steps. We are going to follow these steps very specifically. So pause the video at this time, go ahead and jot down your steps, and then we're going to go through them together. You can hit resume as soon as you're ready. All right, ladies and gentlemen, here is our example. We're going to go ahead and follow those steps. And our first step is to write the formula for the volume of sphere. Okay, so I'm going to give myself as much room as possible. 4 times pi times radius cubed divided by 3. And then we're going to go ahead and substitute in the values we know. So in this problem, the only value we know is that the volume is 57. So I guess that's not really true because we know the value of pi is going to be 3.14. So we can substitute in that value as well. Okay, now our next step is going to be to multiply anything on that top portion of our formula. So in this case, I can multiply 4 times 3.14, and that should give me 12.56 times radius cubed divided by 3. All right, our next step is going to be to try to get rid of that divided by 3. And just as a reminder, when we're solving equations, and what we're really doing here is trying to isolate r, and so it is solving equations, I want to use inverse operations to basically undo some of the math that is happening. So in order to undo divided by 3, I'm going to do the inverse operation, which is going to be multiplied by 3, but I need to remember to do that on both sides of my equation. Okay, so my undos, my inverse operations, cancel each other out. Okay, so that means that on the right side of my equation, I have 12.56 r to the third power, so no more fraction, which is great. On the left side, we need to multiply 3 times 57, and that's going to give me 171. All right, my next job is to isolate that r cubed, so I want to get rid of that 12.56 that's being multiplied by it. And again, an inverse operation is required here. So we're going to divide by 12.56 on both sides. Okay, that's going to eliminate my inverse operation here. And that means that r cubed will be isolated. Now, when I take 171 divided by 12.56, I'm going to end up with 13.6146, blah, blah, blah. One mistake that some students make is they stop right here and they think, well, r is isolated, so we're done. However, we are trying to figure out the radius of this sphere, and right now the information we have is that the radius cubed is equal to this. So in order to figure out our radius, our actual radius, if we have r cubed, we're going to need to cube root both sides. Okay, so here's how that looks. The cube root is written like a square root, but inside that little check area, we need to put a 3 so that we know we are cube rooting, not square rooting. We're going to do the exact same thing. We're going to cube root on the left, and we're going to figure out the cube root of 13.6146. Now, many of you have probably not done cube root on your calculator, so I am going to demonstrate. how to do that on this calculator. This calculator, you will notice, has a square root button. It's a second function key, so that means the square root symbol is above the x squared. And directly above that, where I have my exponent key, it looks like this little tent here. The second function of that key says x to the root. Okay? In order to use a cube root, we're going to need to use this key. And we have to tell the calculator what type of root we're looking for. We're looking for a cube root. So we're going to hit the 3, then second, and that root button. Now take a quick look at the screen. This is what it's going to look like. This is telling us that we are cube rooting whatever number we're trying to find the cube root of. We're trying to cube root 13.6146. So once I've entered it, I hit equals, and it looks like the cube root is equal to 2.3878, and that means that our radius is equal to 2.3878, etc. We're going to round to the hundredths. We're going to make that 2.39 inches for the radius. All right, next up, let's say we know the volume of a cone. We're trying to find either the height or the radius of the cone using the formula. Go ahead and pause the video at this time, make a sketch of this cone problem, and go ahead and jot down the steps. Some of the steps are similar, but some are a little bit different. We will go through this together just as soon as you hit resume. All right, ladies and gentlemen, we are going to start by writing the formula for volume of a cone, which we know is volume equals pi times radius squared times height divided by 3. Okay, now we're going to then substitute in our known values. So we do know that the volume of this cone is 55. We know that pi is equal to 3.14, or approximately equal to anyway. It looks like we don't know the radius, so I'm going to leave that as r squared. But we do know the height of this cone is 5. And don't forget you're divided by 3. All right, next I'm going to try simplifying some things here. So I'm going to combine the things that I can up top here, and 3.14 times 5 gives me 15.7. So I can rewrite that as 15.7 r squared over 3 is equal to 55. And next we're going to get rid of that divided by 3. We just went over that in our last example, so we're going to do the inverse operation of divide by 3, which is multiply by 3. And our inverse operations are going to cancel each other out. So that leaves me with 15.7 r squared on the right. Oops, 0.7. Ooh, that's a little messy. Sorry about that. 15.7 r squared on the right is going to be equal to 3 times 55, and 3 times 55 turns out to be 165. All right, next up we are going to try to get that r squared isolated. These two items are being multiplied together, so our inverse operation is to divide by the coefficient, which will cancel out our 15.7s. Leaving us with r squared isolated. Now, 165 divided by 15.7 gives me approximately 10.50955. Actually, that keeps going, but I'm going to end it right there. And again, here we want to know what the radius is, but what we have is r squared. So we're going to need to square root both sides of our equation. Okay, now square root is a little bit easier, and we do have a square root button on most scientific calculators. So this time when I turn on my calculator and square root, I'm going to go to my second function key. It's still above a key, and hit the square root. So this is what it should look like on our calculator. That square root, usually it'll have a parenthesis there, and it will look slightly different with different calculators. So if you're not sure how to square root, please double check with your teacher. I'm sure your teacher can help out with that. Okay, and we are square rooting 10.50955, and I end up with 3.2418 equals R. I've been very oftentimes rounding to the hundredths place, so that's going to give me 3.24, and we are dealing with inches in this problem. Our radius is going to be 3.24 inches. All right, ladies and gentlemen, I saved the easiest one for last. Finding one of the dimensions of a cylinder when we know the volume. Go ahead and pause your video at this time, make a sketch of the problem, and jot down your steps. As soon as you're ready, hit resume, and we'll go through them together. All right, we are going to start by writing our volume formula for cylinder, which is pi times radius squared times height. And then, of course, we're going to substitute in the values we know. Our volume is 77.872. Pi is equal to, or approximately equal to, 3.14. This time the dimension we're given is the radius, so 2 to the second power. And height will stay height since that's the value we are trying to find. Okay, on this side I am going to go ahead and square 2, which is 4, and 4 times 3.14 is going to give me 12.56 times the height. And all we have to do to isolate h now is divide by 12.56, and we'll do that on both sides. Our 12.56's cancel out on the right. And when I divide 77.872 divided by 12.56, I end up with 6.2. And our label for this problem is feet, which means that the height of this cylinder is 6.2 feet. All right, ladies and gentlemen, you definitely have enough to get started on your practice work. Good luck to you. Have a great day.